A kangaroo jumps straight up to a vertical height of 1.45 meters. How long was it in the air before returning to Earth?
This one's pretty straightforward. What do we know about this kangaroo and what do we want to find?
We know that starting from a resting position, it reached a vertical height of 1.45 meters. I have a feeling that even though they don't give it to us in the problem, we could use gravity to help solve it.
Yes, we know that the acceleration is equal to gravity, which is negative 9.8 meters per second squared. Also, you said it started from a resting position, but that's not technically true. It had to start with an initial velocity, right? In order to be
Oh,
moving up.
okay. So, we want to know how long it was in the air.
Right.
So
We want to
isn't
find the time.
1.45 the initial?
1.45 is the height it makes it to. We
Oh,
can
it's the
consider
height.
the initial position to be 0. So we have a few things so far. I'm just writing them down casually here. We're looking for the time it's in the air. We know that the change in vertical position, I put delta y to represent vertical instead of delta x, is equal to 1.45 meters. We have that the acceleration is negative 9.8 meters per second. Let's talk really fast about initial velocity and final velocity. This is kind of tricky. So we have our kangaroo on the ground and it's about to leap up in the air. So once it goes, its initial velocity is going to be somewhat significant. But whenever it's actually up in the air, it stops, right, momentarily. So when it's actually at the top, we can consider this to be its final velocity if we want to. Now, if you throw a ball up in the air at the very top of the trajectory, what is its velocity going to be? At the bottom, it has some initial velocity. But at the top, for a split second, its velocity is 0, right? Because if it's only moving vertically, then at the very top, it had to stop and then start moving back down. So our initial velocity is unknown, but at the top, we can actually know that the final velocity is 0 because it's turning around. So I'm going to put that in here. We actually can put that v naught, the initial, is unknown. Now keep in mind, if we use this as our equation, then we're going to get that the amount of time we calculate is only the amount of time that it takes the kangaroo to go from the bottom of the jump to the top of the jump. Then we'd have to double that time in order to get the amount of time it takes to fall back down to its original jumping position.
So whatever we solve for time, we have to multiply by 2.
Yes, exactly. Perfect. Let me write down the kinematic equations. V final equals V initial plus AT, not equals AT. Delta, I'll put delta y here since we're dealing with the vertical direction. Those are always interchangeable. Delta y equals V initial times time plus 1/2 AT squared, and V final squared equals V initial squared plus 2a delta x. I'll even include the fourth. This one we have delta y equals v final plus v initial over 2 times time. Which equation should we use here to calculate the amount of time it takes the kangaroo to go from the bottom to the top?
Could we use v final equals v initial plus acceleration times time?
Let's see, what is v final?
V final is 0.
Nice, what is v initial?
We don't know v initial.
Right, what is a?
A is negative 9.8.
And what is t?
We're solving for t.
Right, so since we have two unknowns, we can't actually use this one, can we?
No.
Let's try for the next one. What's the next one you want to try out?
Could we try number 3?
So, does number 3 have time in it?
It doesn't, but could we use it to solve for v initial?
Actually, yeah, that's not a bad idea. We could use it to solve for v initial. Let's do that. So we have v final is 0 squared equals v initial That's what we're solving for, plus 2 times negative 9.8. And then delta x is, or delta y in this case, I should replace that here, just for the sake of this equation, is going to be 1.45. Now it's just a matter of doing the algebra. Let's simplify this first. We have the 0 goes away, so I'm going to do v naught squared. Basically, I'll subtract all of this to the other side. So we did it minus all of this here, minus 2 times negative 9.8 times 1.45 on both sides, and we end up with v naught squared equals a negative of a negative is a positive, 2 times 9.8 times 1.45. Finally, all we have to do is take the square root of both sides, and we get the initial is equal to the square root of 2 times 9.8 times 1.45. Go ahead and punch that in. Let me know what you get.
I got 5.33.
That's what I get. Perfect. What are the units?
The units are, is it meters per second?
Yeah, awesome. I'm going to circle that, and I'm going to take out how I crossed out the first equation, because maybe now we can use it now that we have the initial velocity. So now, what are we going to use to calculate time now that our initial velocity is known?
Could we use number 1 now? Because time would be the only thing we don't know.
Yeah, absolutely. Can you set it up for me?
V final equals 0. So it's 0 equals 5.33 meters per second plus negative 9.8 meters per second squared times t.
Awesome. Let's solve for time.
So we want to get time on its own. Do we want to subtract 5.33 and negative 9.8 to the other side? Or is there a better way to do that?
You're right. We just subtract 5.33 to the other side.
Okay.
So we get negative 5.33 equals negative 9.8t.
Okay.
Now, the negative 9.8 is attached to t by multiplication.
So we have to divide that.
Yes, exactly. We move it to the other side by division. And that should give us our solution. Let me know what you get for the time. Remember, a negative divided by a negative is a positive. I know you know that.
So I got 0.54.
Perfect. What's the unit?
Is that seconds?
Yes. Now, did we solve the entire question, or do we have one more step? What did that time, what was that the actual time of?
We have to multiply it by 2 because what comes up must come down.
Yeah, perfect. Let's do it. So I circle anything that's not the final answer, and the final answer, I'll call this time total is equal to t times 2, because exactly what you said, what comes up must come down. Let me know what you get.
I got 1.08 seconds.
Perfect. And I'm going to round it to 1.09 because I got 1.087. Perfect. Yeah, great stuff. Is this making sense?
Yes.
Awesome.
I saw that we could solve for one part of the equation to use another equation to solve for time.
Yeah, that was good. You caught on to it before I did. I was feeling lazy and not really looking for that. But that was a great way to solve the problem. And great stuff today. I feel like really no errors on this. No mistakes. So yeah, awesome.